everyone, welcome. My name is Strom. In today's Learn Redstone with Strom video, I'm going to be covering my Gravel Golem Killer machine. This is just something that was made for fun, but we're going to go over this. And then, of course, as usual, I'm going to be running through the circuits, and down in the video description will be a timestamp for each of those if you wanted to skip all this. But first, we're going to go over what the Gravel Golem Killer machine is. Then I'm going to go through the different circuits that are involved with it. So let's get to it. In my All About Villagers video, I actually covered how you can spawn iron golems in an iron farm. But then the question comes of actually killing them. There are a lot of ways that you can do that. Right here, we can just see one of our golem friends and he spawned. Okay. One of the ways you can do that, as we see here, is with magma blocks. They'll take damage on top of those magma blocks. Another way is on top of campfires. They'll also take damage via campfires. The nice thing about campfires is you can just put a hopper directly under it and collect the iron that way. And as you can see, the campfire here with the blue soul campfire is actually significantly faster than the magma blocks over there. Okay, so that's a nice fast way. We can see he's taking more damage, and even though he was spawned later, he's actually going to die first, as we see there. Probably one of the fastest ways to kill a golem is right here, as we see, in lava. So they're going to take the most damage in lava, but they have high health, so they still take a long time to actually take damage. Now, all of these methods are fine and dandy. They work well, but they're not fun. So I was recently challenged by a friend of mine to try and come up with a new way to kill golems, and the suggestion he had was gravel. Gravel. That's going to kill golems with gravel. What? Well, let's talk about how we can do that. So if you remember, as we talked about in the All About Villagers video, we look at the hitbox of a golem. It's pretty huge. So in this little 3x3 glass cage he has here, no matter where he's standing, his hitbox is somewhere on that center block. So if we have some gravel that we drop on him in that center, he's going to start taking suffocation damage from his hitbox being inside that gravel. You'll notice this is going to take a long time for him to die. And now he's finally dead. But it worked. As you can see, we have iron waiting there on the ground for us. However, this is not repeatable, because if we were to just have another golem dropping into this chamber, he would just land on top of the gravel. And he would just happily stay there. In fact, in this case, he's just going to walk off. He's perfectly fine. We're not going to be getting any iron from him. Terrible. So I came up with this machine. So this machine is dependent on quite a few things to both keep an iron farm efficient, as well as be able to work it repeatedly. We're going to be going over those circuits in detail, but this is just a quick overview. So the major trick here is how do we get this gravel back up above the golem and drop it back down on him. You'll notice with gravity blocks, when we put them on pistons, we can't just push them upwards, because even though it will push upwards, as soon as our piston retracts, it's going to fall back down. So even if we have a stack of it, we push it up, all four get pushed up, we'll hit that, and all four drop back down. So we can't just use a piston wall to just push it up and up and up. We have to use a few different techniques. So first I'm going to talk about how the machine actually works, and then I'm going to talk about how it can actually still keep an iron farm efficient. Okay, again, it's probably going to be easier to make your lava traps or your campfire traps, because it's going to kill them much quicker, and it's going to be much easier to actually then collect those drops from them. However, if you want a fun way to do this, this is a nice fun way. But this is also just a good excuse to learn some more redstone circuits. So let's review this. First, we need to drop the gravel down. Okay, so once this piston right here opens up, the gravel is now free to fall from gravity, and it'll drop down. But it's going to drop down in its stack again, so we need to get it back up. What we have here is we have a smart piston that's going to push all those blocks over onto this machine right here. This machine is a flying machine, so this is going to fly up with the stack of gravel, go all the way up here way above the golem. These pistons are going to unload the gravel from that machine. Okay. Then this flying machine is going to actually take those gravel blocks over to the center again, where they're going to fall back onto this smart piston, and drop in a stack back on top of the golem. We're going to watch this machine in real time, and then I'm going to go through a little bit more in detail what it's doing, and then we'll get into the circuits. There it goes. It loads up onto the flying machine. The flying machine carries up our gravel, going all the way up here. It's going to unload. It's going to stuff it under this flying machine, which is going to carry it back over onto that smart piston, drop it onto our golem, who is now going to start taking his suffocation damage. Because he's on soul soil here, soul sand, those drops are then going to fall through to this hopper when it's all said and done. And over here underneath the piston, we have a hopper minecart that will also collect those as they go through. And so we're still collecting all the iron. Now, we went over briefly how this machine works and the different components that are actually used in it. But now let's talk about how it actually manages to keep efficiency. So this machine design is actually meant to be created inside the Nether. If you remember in the All About Villagers video, we talked about how you can push a golem through to the Nether, and the villagers will now recognize that that golem is gone and be available to start spawning a new golem that much quicker. So when they're in the Nether, it does not matter how fast we kill them. All that matters is, are the villagers on the other side able to keep sending them through? So over here, I just have a kind of a weird little iron farm. Again, I'm kind of going for some ridiculous stuff here. We have our zombie cage made of diorite. Ugh. Anyways, we're scaring these villagers here, and they're spawning golems on this platform. Now, you may say, I haven't seen any golems come through there before, but you'll notice this has been running for a little while, and we have quite a few golems, okay? We have golems taking actual entity cramping damage. So there are 24 golems per corner here. They're all waiting just to get suffocated in that gravel. So, if I go ahead and set off this machine here in the Nether, we're going to see all these golems here are going to start taking that gravel damage. Again, the flying machine takes up the gravel. We'll look at it from this perspective this time. Unload the gravel, move the gravel over, send it down on top of the golems, and there we go. Move away a little bit because that's loud, but now we're killing almost 100 golems at the same time and collecting all that iron, and of course this useful poppies. I'm kidding, no one uses poppies. And see, now they're all dead, and we're collecting all their stuff, putting it down into an item sorter here, and we're getting our iron. Since this is running pretty slow, we do actually need the chunk loader in order to keep this area loaded and make sure the machine does not break and efficiently kills off those golems. I'll load this up and let this run just for a moment so we can see they actually are spawning golems at a pretty decent rate. So they are making golems. This is, again, not the most efficient iron design. This is not a video on the most efficient iron design. This is just a video on how to efficiently, ridiculously kill off golems. So let's now move on to the redstone learning portion of this video and get into all the different circuits that are used inside this video. A couple of them are going to be refreshes, but some of them are new things that I haven't covered before. So let's get into it. These are all the circuits that we're going to cover, and this will be available in the world download as it originally was, so you yourself can come in here and test these out for yourself and see what they're doing. And inside each of the chests next to them, I have the materials that you'll actually need to make these things. But let's go ahead and review these things. So right here we have smart pistons, okay? What a smart piston is it's a piston that as soon as a block is in front of its face, it pushes it out of the way. This is the method that I'm using inside the Golem Crusher. We have a torch with a repeater, and that repeater is right now pushing into an air block. But if there was a regular block here, it would then send a signal over to this redstone, which would then power this piston to push it out of the way. As soon as that piston is extended, this power can no longer go through this block, and this redstone will turn off. So it will push it in a line. We can see there, every time I put a block down in front of there, it's going to just push it out of the way. Now, this does depend on piston limit. As soon as we hit that 12 push limit, this is going to stop. This is the original design of the smart piston. This is using a redstone torch that is below the air block that will be turned into a solid block. And that solid block will then power this redstone and send it through there. So same concept, just with the power below instead of on the side. Now in the Golem Killer, I didn't want it below because I didn't want that gravel to actually fall right through this. Because if we were to put gravel on here, it would fall through this torch. If it landed on the block where the torch is, it would then break the gravel. So that's why I use this model over here, but this is the original smart piston design, and it's going to do the same thing. Push that block out from its face. This here is what's called the zero tick smart piston design. What this is doing is, you'll notice as we pushed out from here before, it was going a little bit slow because it takes a few ticks to realize, you know what, that redstone is actually off. I should pull the piston back before I can put down another block. So if I was to just hold down the mouse button, it's decently fast, but we could make that faster. What this setup is doing is this sticky piston on top of this piston is giving this another block update. This is something we haven't talked about much, so I'm just going to do a real brief description of this. When a block changes its state, so here we have a piston that would go from retracted to extended, that causes the blocks around it to also have a block update. And they will check to see, am I supposed to be in the state that I'm in, or should I refresh? So by having this redstone signal set off both this piston and this piston, the game is going to look at it and say, oh, I'm actually not powered. I need to update immediately. So this is going to be much faster. Now if I hold down the right click in front of here, we're going to see that's going to go much faster. I'll run that again, and I'll try and look this direction. Come here and place it on top of the torch, so we can see how fast that's moving. And what that's doing is it's this piston updating here is forcing this piston to then update, which is then updating this piston. So they're updating each other and saying, wait a minute, we're not actually powered anymore. Forget this. Get back to your original position. We can also use smart pistons in tandem with each other. So what this system right here would do would be to push a row of blocks in front of these pistons. Once it hits this smart piston right over here, it then sends out a signal to here, which then triggers off all these pistons, and then also triggers off all these pistons. So what it's going to do is it's going to turn one block that we're placing stone into a wall of stone. And I'll show you that now. See that kicked off there? Let me come to this side so we can actually see that a little better. And now it's going to start pushing it up. Let me just come over here and we can watch. This is going to end up going pretty high here. So this can be useful for maybe something like some sort of spleef arena setup, or if you wanted to actually push some blocks in front of some dropping TNT to blow those up constantly. So maybe this is concrete here and you want to actually push it down over a water source and make yourself a concrete maker that way. But we can do that so that if we had, you know, water right next to here and we put some concrete powder here, it turns into concrete, and then it all gets pushed together and then TNT blows it up. But those are what smart pistons do. It's anytime there's a block in front of the piston's face, it pushes it out of the way. This right here, this is the Etho hopper clock. I did cover this briefly in my video about the signal input limiters. However, I wanted to bring this up again because this, in my opinion, is just a very useful clock to know. These are all the materials you need to make it. It's a very resource cheap clock. Okay, really the most expensive thing is going to be those 2 slime balls to make the 2 sticky pistons. But other than that, you really have, I mean, you have 2 quartz in the redstone comparator. You have some redstone here, but that's about it. And all you're doing to make this is you are having 2 hoppers that face into each other. Okay? Items want to run back and forth between those. However, since there is a block of redstone on top of one, it's locking that hopper, so that hopper can't move. If I was to take this out, we would actually see those items are just going to pop back and forth between the 2 hoppers. Now, on the outside of each one of those hoppers, we have a comparator that's coming out, and it's checking for, is there any signal in there? What's going to happen is when this hopper is empty, you'll see now this comparator is turned off while this one is turned on. it's going to turn off this redstone, which right now we just have on by a lever, the on-off switch, which is then going to retract this piston and allow this piston to push the redstone block over to the other side. Now this side is going to be locked, not be able to take in any items, but it's going to send all its items to the other side. And that's how that timer is working, by sending these items back and forth. And each item going through a hopper takes 0.4 seconds. So we call that hopper speed. Hopper speed is 0.4 seconds. And what you can have is you can have as little as one item in there to run a clock for 0.4 seconds each direction. So that would be 0.8 seconds to go back and forth. Or you can have 5 full stacks in here, in which case you can run it for, I believe it's something like 260 seconds. So you can have a very short or a very long timer using this system. So this Etho hopper clock is a very useful circuit to know if you want to do redstone clocks, because it is extremely controllable. One of the things I did cover in my other video as well was pulse extenders. And we talked about flip-flops, but we didn't really talk about just pulse reducers. Okay, and that's one of the things I'm using inside the system here, and we'll go back into that a little further. But what it's doing is when we push this button, it's going to stay depressed for a while, and it's going to continue to send a redstone signal. But if we just want a quick signal to come out of it, say for example, we wanted just a quick signal to come out of this redstone block when it moved over, we didn't want to have signal for the entire time that this redstone block was in place, we can use a reducer. So what this is going to do is it's going to send a signal into this repeater. This repeater is then going to power this block, which is going to power this piston and push this piston up. But in that brief moment before it pushes it up, signal is going to go through to this repeater and then be able to come through to this lamp and piston. However, as soon as this is extended though, signal is no longer going to be able to go through. So we're going to see a long signal on this side equates to a short signal on this side. And I'll show you that now. So you can see this repeater right here only takes a quick pulse. And it doesn't matter how long this stays on for, that lamp on that other side there is not going to light up as long as this piston is extended with that yellow block on top of it. Adversely, again, I just real quick want to cover a pulse extender. This is a comparator pulse extender, so this means that when we press this button, after that button turns off, this signal is going to loop back and forth through these comparators, and it's going to reduce its signal each time it loops through. So it's going to reduce from 15 to 14 to 13 to 12, etc., until it's completely gone. So what we're going to see is when we push this button this time, these are going to stay powered for longer than the button press. And we can see that with that redstone getting gradually darker and darker until finally everything turns off. This is a circuit that I have covered before, but I'm going to go over this again because this is included in here. In this model, we are not actually using the poppies that are coming out of the golems and putting them into a composter. You could, however, I want to take this opportunity to go over the dropper clocks again. So again, everything you're going to need is in here. So this is our dropper clock, and what this does is anytime there's an item in here, it's going to activate this comparator because it's going to compare how many items are in here. If there's at least one, it's going to power this block, which is going to push this piston and push these observers so their two faces are hitting each other. Let me just grab some items here. We'll grab some polished diorite because why not? As soon as we put something in there, see, it's going to turn on that clock and we're going to see all those items shooting out. Now we could just leave it like this so that these items just fall to the floor and just stay on there and wait for them to despawn. However, since we have that chunk loader going, we don't actually want to do that. We don't want to create any more entities than we have to. So over here, we have the same circuit on this side, but you'll notice there's also some ice underneath it and then a cactus. I just real quick want to cover what those are going to do. So items, when they are shot out with velocity on ice, are actually going to slide across that ice until they hit a solid block, or I believe it's about 9 blocks that they can travel. So if I just take some of this dye right here and put it in there, as we see, even though it's landing over here sometimes, it's all going to slide over to here because items on ice will slide around. And I'll even show you that here if I can move properly for once. Let's take this item and let's throw it onto that ice. And we're going to see it slid all the way across there. Whereas if I had done that over here, as soon as it hits the ground, it stops. So it's going to slide around on that ice. And we can use that as another way of transport And with this cactus, what happens is anytime an item falls onto a cactus, it is immediately destroyed. Just like you were to throw it into lava. But what we're doing here is this time, any items that come in here, and let's actually do it with the poppies this time. Any items that come into here, they're going to slide across the ice, go into the cactus, and get destroyed. And you'll see those poppies are all disappearing there. And what that's doing is that's going to help us with our lag situation on the server. If this is a server, if it's single player, it may not be too much to worry about, but all those items are going to slide into that cactus and be destroyed. Another type of circuit, or maybe not necessarily circuit, but signal transmission method that's used in this model is observer lines. And all we need for this is just observers. Just observers. So as we can see here, the observer has a face on it, and it has a backside on it. What happens is when that face detects an update from the block in front of it, it's going to send a redstone signal out the back of it. However, an observer can also observe when another observer is changing state. I know there's a mouthful, but let's put this right here. So that observer is facing into this one. When we do something to change this state, that observer is going to pick it up. Okay, we could put one here on the top, put one here on the side, put it on the back. All those are now lighting up. But you'll notice this one is not lighting up because it's not taking in a signal from those. It's only recognizing where there was a signal change previously. So we can end up then chaining those together. So if I was to chain these this way, chain those that way, we can see they're all facing into each other. When I put a update in front of this one, it's going to travel through and go to this one because this one is detecting this one changed, detecting that one changed, detecting that one, detect, etc. The nice thing about this is those don't interfere with each other. So if we were to take redstone here and we were to just put two lines on the ground, and let's say we had two different lamps and we wanted those to be controlled separately, we can't do that because each lever is going to send signal through both of those. Let me just throw some redstone on there. See, that will control that, that will control that. So there's no way to keep those separate. However, when you have an observer line facing like this, those are not going to interact with each other because this line is not concerned with this line and this line is not concerned with this line. So over here I have an example of that. Let me just break that out of the way there. We have a redstone line going right in the middle here, and we'll notice that lamp and piston turn on, but this one do not. And same thing here. If I was to put a observer facing in here, we're going to notice this is going to snake over here and start clocking that. You notice there was a bit of a delay though. There is a delay from when a repeater will actually light up and send out its signal there and then be able to reach the next one. So we can actually use an observer line also as a delayed signal of a way to get it over there. Now this system does use some observer paths, some observer lines that are, you could argue, unnecessary because you could do them with repeater lines. However, this can just kind of keep it nice and cleaner. Another nice thing about observer lines is they are waterproof. So you cannot put redstone underwater or redstone repeaters or comparators, anything like that. But observer lines, they can go right through water. And okay, they're not bothered by any of that. Over here, I have another example of where we can send a signal through this line right here. And then we have observers on the outside detecting when each of those stages go. So this will show that we can pull those signals off, and we're using this to unload the machine as we go through snaking that signal. But we can see that it's actually going to kind of wave through. Let me just do that once to show you. You'll see it takes a little bit of time to get around, so we can use that to our advantage as well. Here we have the slime block mob pusher. What this is it's a way to automatically push a mob that comes onto an ice path. Now, in this case, we're using it to push those golems outside of the portal. This doesn't necessarily have to be on ice, but the nice thing about ice is it's going to push them for a longer range. So let's grab some creeper eggs here. We'll use those for an example. What's going to happen is when a creeper steps on this pressure plate, that's going to activate this repeater, which is going to power this block, which will then activate this piston and push the slime out. And whenever an item or an entity like a mob gets pushed by a slime block, it's going to also gain some extra momentum. So if we were to have just solid blocks here, it would just go a few blocks. But if we were to put it on ice, like over there, we'll see in a minute, they're going to go farther. So I'm going to go ahead and I'm going to spawn a creeper above it. And what's going to happen is he's going to land on that pressure plate and set this off and get immediately pushed off to the side. See? So we went there with some velocity. Now this is an example here where we can actually guide how far he's going to go and push him into these magma block sections. So I'm going to come up to the top here, and it's the same exact circuit on the back side of here. Notice we do have some glazed terracotta because, again, there's a slime block in there. We don't want that to stick to anything as it's going through. Otherwise, it either won't activate or it's going to start ripping apart the system. So I'll put a creeper in there, and we're going to notice he's going to slide all that way. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks, and then fell into the 10th one. So that's because we're using ice. If we're using solid, he would only get pushed a few blocks. But we can use that to push entities around. And in this case, for this machine, we're using it to push the golems out of the portal. So this is the flying machine that's going to be used in the system. This is a tileable version. And if you're looking for more detailed information on how flying machine works, I have another video for that on my YouTube channel where I describe in detail how these flying machines work. So if you want to know that, go ahead and pause this video, go check that out and come back here. I'm going to be covering just the tileable version here. And I have everything you need. You're going to need honey blocks, slime blocks, observers, sticky pistons, and then to actually set off the machine, which we'll talk about in a minute, you're going to need some obsidian and some way to send signal to all those things at once. So over here, I have just one slice of this tileable version. Okay, and what we're doing here is we're using the redstone to update this observer and send it upwards. And then here we're using a piston to update this observer and send it downwards. Now what we have over here in the tiled version is, you notice we have alternating slime blocks and honey blocks. That's because both slime blocks and honey blocks will stick to other blocks, but they will not stick with each other. So if this was to be all slime blocks, this would be far over the push limit. This right here would be 8 alone. Throw this in, we've got 12, and boom, right here we're already at the cap at 16, and we still have a whole nother side to go. And this can be theoretically extended out to a, I guess not infinite, loaded chunks and flying machines and all that sort of thing, but this can go as far as you need it to with this tileable design. What we have is we have same thing, that redstone line is going to update these observers, so when you hit that button, this redstone line is going to activate every one of these observers at once, and it's going to all travel up together. Now, it's going to look like those blocks are moving together, but they're just moving at the same time because we updated at the same time. And here's the same thing with those pistons. We have this line coming together to go all at the same time. So this does look like it's moving together, but it's just all moving each slice at the same time. Over here, I have an example set up to show what would happen if they were moving at alternate times, because eventually the blocks, the sticky blocks, would reach to these other portions and stick to those, the pistons and the observers. So if I was to hit like this middle one and the side one, then this one, and then that one and that one, we're going to see it broke the machine. It took these pieces with it. Those went there. Let's try and send that one up. We can't because its pieces are missing. Same thing there. Its pieces are missing. So the whole machine broke. And, you know, we can try and send this back down. Let's grab a button. And now it's just stuck on that side. It never actually reached down to the bottom. So when you use these tileable flying machines, you need to make sure that you're updating every single observer within the same exact tick. Okay. There is a little bit of leeway if you were to do them within 1 or 2 ticks, but if you're going to do this tileable design and you want to make sure it doesn't break, just update all those observers at the exact same time. We can see over here that this model with tileable will also work going horizontally, but we're not using that same kind of standard design that we did before, because honey blocks, if you'll notice, you can see kind of through those slime blocks there, and you can also see through those honey blocks, but honey blocks actually have a smaller hitbox than a slime block. They are not a full block. So if I was to go into this block and try and move, I can't, because I'm actually hitting the corner of this piston. Whereas with the slime blocks, that doesn't happen because these are full blocks. So you can transmit redstone signal through a slime block, but not through a honey block. So that's why we're using this model of flying machine horizontally instead of the model that we used in the previous version for learning flying machines, but it's the same concept. This piston pushes this module forward, which activates this, and then this piston pulls this module back to it. And we can see this is going to also work horizontally, so it's going to be the same concept. Another thing we're using in this machine, obviously it's based in the name, is gravel. Gravel is a gravity block. So that means if there's no block supporting that gravel block, it will then fall down until it reaches a non-gravity affected block. So I'm going to pull out some gravel here, and what we're going to see is gravel won't actually stick to the side without being supported of a sticky block. So once I place this gravel, it just falls directly to the ground because it's not being supported by anything. So when we use the flying machine inside that system to actually pull the gravel back over to the pit where we want to drop it, we're then supporting it with these blocks here. Because the gravel is supported, it will then be able to stick to the block that's above it. So if I was to put some gravel in here, we're going to see that if I set this machine off, it's going to drag this gravel across. It's going to stick to that until it hits this spot right here where it's no longer supported. And then it's just going to drop down into that hole. So we'll send this machine and we'll see how that's working. It falls right through there. And what we're doing in the design of the Gravel Golem Killer is instead of falling into a hole, it then falls into place onto a smart piston. Last but certainly not least, we have the chunk loader. What a chunk loader does is it keeps chunks loaded for you in an area where you are no longer going to be playing the game. So when you fly away from an area, if I was to leave this area and just fly off, it's going to start unloading those chunks that are behind me until eventually all these contraptions here are going to now be unloaded, meaning they're not running. They're no longer in the game until I go back to that area. And we can see now all those machines are completely unloaded. That's because the player is no longer in range of them. However, we can do something using a chunk loader to keep that area loaded no matter where the player goes to. And that also works with the chunks in the nether too, the way that we're doing this. So this is a construction using a nether portal for a chunk loader. What this does is the chunk that the nether portal is in is going to stay loaded, as well as the adjacent chunks. So you're going to have a total of 9 chunks that are loaded. You can see this outline that I have set up to show the chunks and those other blocks to show the inside chunk. I'm going to go ahead and turn on the chunk border so that we can see this. So right now we're in one chunk, here we're in another, here we're in another. So all 9 of these that are surrounding this center chunk right here, this one, are going to stay loaded as long as this portal is active. What happens in Minecraft is as soon as you go through a portal, the area that you left behind stays loaded for 10 seconds. That also applies if an item gets thrown through a portal. So if I was to throw an item through this portal, the nether on the other side of that is going to load up to accept that item and then stay loaded for 10 seconds. If we constantly are throwing items into that portal through droppers less than every 10 seconds, that will then stay loaded indefinitely. However, the problem then comes of how do you keep the system from running out of items? And that's what these hoppers are for. Let me show you the backside here. So what's happening is this dropper that you can see through the portal is shooting items through the portal. On the other side of the portal, we have this exact same setup, and I'll run through this a little more in detail, but it's then shooting items from this portal this direction. The items hit this glass pane, fall into the hopper. The hopper then carries it over through this hopper line over to this dropper. And then what we're doing is we're doing another dropper clock. However, this time what we have is this dropper is actually facing up into this dropper, and this dropper is facing sideways. So the item comes through this hopper into this dropper, gets shot up into this dropper, and then shot through the portal. The way that we're doing this is through this comparator clock. And what we're doing here is whenever a signal gets sent into this comparator from an item being in here, The comparator sends out a signal, which we pick up with this repeater. Then we loop it back around and send it back into the side, which then turns off this comparator. So this kind of goes in a loop of, I have an item behind me, I'm going to turn on, send out a signal. Oh, I have a signal coming into the side of me, turn off. But I have an item inside me, so turn on. Oh, turn off. Oh, there's an item, and it just goes around and around until there are no more items left in this dropper. We then have a signal coming off the side here using a repeater to go in, and the repeater signal going into this dropper will also power this one. So it's going to send through those pulses, and it's going to shoot up through there, and then the next round it's going to shoot over through there. So in order to keep this active, we just need a decent sized stack of items, and this is a pretty good sized stack of items. In fact, we could probably realistically keep this running with maybe about 6 or 7 items in there. However, because we're going to be going through the portal and golems are going to be going through the portal and there's a chance that we may pick one up while we're working on it, there's no harm in just adding in a bunch of extra items in here. What's going to happen is those are going to go through the nether and then get caught on the same circuit on the other side. And we can see that here. We have the same exact circuit, but you'll notice this one is not sending off any clock signals. This one is just completely dead. Even though it's the same exact circuit, it's not doing anything. There's no items in it. There's my diorite that I threw through there, but it's not doing anything. The reason that is because here in the overworld, I have this lever turned on, which now stops this dropper from being able to take all these new signals. So if I turn this lever back off, it's going to allow this clock to start working, and it's going to start throwing them back and forth to each other. So now we can see it looks like that thing is just shooting the yellow concrete through the portal into that hopper, but it's not. Those yellow concrete bricks coming this way are actually coming back from the nether. And as you can see, occasionally it's shooting that white diorite back through. And that's what's keeping it loaded. So now this chunk and the surrounding 8 chunks are now loaded for 10 seconds each time one of those items goes through. And that's one of the reasons why we've added this little bit of delay right here, is because we don't need this to be a fast clock. We don't need it to shoot that fast because that's just going to be overkill. We just need to make sure that we're sending an item through at least every 10 seconds or less so that it stays loaded on the other side. What I have here is just a very simple timer. It's just a chest full of items with a hopper that is locked, so it's not going to send any items through, and it's being locked by this lever. In the world download that you can use for this, you can actually go ahead and turn on that chunk loader, start this timer by flicking this lever, and you can see that this is going to continue to drop items into the chest while the chunk loader is active, even when you're in the nether. We can see now we're spitting out golems here. We are back at the machine, and now that we've run through all those circuits, I just wanted to once again run through it a little bit more detail, what kind of circuits we're seeing in this system. So it starts off having a golem come through the nether portal, which that golem farm in the overworld is staying active because of this chunk loader. These pressure plates are then enabling the mob pusher, so that's pushing slime blocks, which then push the golem out into this pit right here. Our Etho hopper clock right here, which is currently disabled due to this lever being turned on, is then deciding how often to send off this system. We're using a signal reducer right here to just send a short signal in, because we don't want it the entire time that this redstone block is over there. We're just extending that short signal out a little bit again. I know that seems strange. We're reducing it and then extending it, but this is a much shorter extension than if this redstone block were to be over there. That would be a much longer run, which drops the gravel down, drops it down onto this smart piston, which then pushes the blocks onto this glowstone. This glowstone is attached to these 4 flying machines, which are tiled to go vertical. The gravel moving through will activate this observer line, and this has just been covered up with carpet just to make it unspawnable. But this is an observer line, and that delay that runs over here to kick off the flying machine gives it enough time to move all the gravel on. As this flies up, This piece of glowstone sticking out the side right here then activates this observer line, which flows over this way, through this side, which activates these 4 pistons to pull the gravel off and unload it. It then loops back around this way, up to here, over to here, which then sends back down the flying machine so that that can reset right over there. It also sets off this piston right here, which activates this flying machine, dragging the gravel across this area. The gravel then, when it reaches here, falls off into this smart piston and then gets pushed on top of the golem. As you can see, again, we're having golems start to back up. That iron farm in the overworld is just working away, and golems are still appearing here. It doesn't matter how fast we kill them in the nether, because even though the nether is loaded, the villagers do not even know about it. Now that we've seen how all the circuits are working together, I'm going to turn the machine back on. See, the gravel drops down, goes onto the smart piston, gets pushed onto the flying machine. Flying machine goes up. Flying machine then gets unloaded, then gets pulled over onto that smart piston and back down on top of the golems, who then get crushed. And because there's soul sand here, it goes right down into the hopper. We are then item sorting the iron, and we're taking the poppies and spitting them into a cactus. I hope you enjoyed this video, and I hope you were able to learn something about redstone circuits, or at least have fun watching this ridiculous machine that we have over here. If you have any other things that you can think of to improve this, I'd love to hear about it down in the comments. This is just kind of something I came up with, again, as a challenge from a friend. They said try and figure out how to squash some golems in some gravel, and this is the machine that I came up with. Again, the world download and the Lightmatica schematic will be available in the description of this video, so check down there for that, as well as the timestamps for everything that we saw if you want to go back and review something. That's going to be it for me today. Thank you all for watching, and I hope I see you later. Bye.